This episode of Epicenter Bitcoin is brought to you by the GTech Blockchain Contest. If you have an idea for a blockchain-related project, make sure you apply for your chance to win awards for 50,000 euros. Go to epicenterbitcoin.com/GTech, that's GTEC, to learn more about GTech and how you can apply. And by Ledger, now accepting pre-orders for the all-new Ledger Blue Developer Edition, a Bluetooth and NFC touchscreen hardware signing device. Learn more about Ledger Blue at ledgerwallet.com and use the discount code EPICENTER to get 10% off your first order.
Hello and welcome to Epicenter Bitcoin, the show which talks about the technologies, projects, and startups driving decentralization, global blockchain and cryptocurrency revolution. My name is Brian Fabian Crane.
And I'm Meher Roy. Today we are continuing with our series on Zcash and on zero knowledge proof technology, and we are going to talk to Zuko Wilcox-O'Hearn, who is the founder and CEO of Zcash. Zcash is trying to implement a fully private, fully privacy-aware, open financial system using zero knowledge proof technology. So we are going to talk about how that will be built and its consequences. But before that, we'd like to have an introduction from Zuko. So Zuko, can you tell us a bit about your background?
Hi there. My background, when I was 19 years old, I discovered the cypherpunks mailing list on this new thing I just discovered called the internet. And there I became exposed to all kinds of grandiose visions of how the combination of the internet plus cryptography plus those two things becoming widely available to billions of people could have all kinds of fantastic consequences. And I've been really fortunate in my life that I've gotten to spend almost my entire adult life working on those things that I love. And the development of Bitcoin was a breakthrough that a lot of the cypherpunks, including me, had dreamed of from the beginning, where the beginning is like 1993 or so, and couldn't figure out how to make that dream real until Satoshi came up with it. And so that breakthrough about what's technically possible, combined with the community of Bitcoiners who were motivated emotionally and politically and morally motivated to invest in it and make it important to their lives, that is what sort of revived the whole cypherpunk revolution in my experience.
So I was in London recently, and I was talking with Ian Grigg there, and we talked. Oh no, it was in Amsterdam. But anyway, we talked a little bit about the history as well of the cypherpunks, and he sort of had this view that there was all this excitement in the 90s, and then a little bit it got lost for a while, until Bitcoin came. Was that your experience as well?
Oh, absolutely. There were many years when I thought I was the last lonely cypherpunk. There was the boom and bust cycles of the internet industry during those years, and there was a widespread narrative that privacy is dead and no one cares. And that's what was from my perspective, completely upended by the Bitcoin phenomenon.
So is Bitcoin something that when it came about, you were immediately like, yes, this is what we have been waiting for, this is amazing? Or were you also, because a lot of people, we've talked with, especially cypherpunks, were initially quite skeptical, and it was like, oh, this doesn't make any sense, it's not going to work. What was your reaction?
I was somewhat skeptical. Those people, including me, were skeptical because we tried and tried and tried. I struggled for maybe 12 or 14 years to come up with something like Bitcoin, and I couldn't figure out any way to make it work. And so when I very first saw it, I was skeptical because for bad reasons. I misunderstood it. I think that's common for a lot of people. But I also thought it was a good stab in the right direction, right? Like, I think progress is made by a lot of variety of small mistakes on different people's parts. So I liked it, and well, I'm the author of one of the earliest blog posts to ever mention Bitcoin on the internet, probably. And what I said about it in this tiny little, like, one paragraph blog post, well, I talked about why an open financial system would be important if it could exist. And then I said, and here's Bitcoin, which is an actual attempt to implement and deploy it. So that's one thing that I think goes a long way that is hard to appreciate, is that deploying a thing to users and having a feedback loop of users using it and changing what it does and changing the way people use it, that's a completely better way to learn than theory and analysis.
So Zuko, like, you are very active on Twitter and you tweet a lot every day, and you tweet very interesting stuff, which is, I think very important for the Bitcoin community as well, because you have such a big body of experience in this field. And there was one of the tweets that I would like to read out and then ask you, what does it mean? Can you state it differently? What does
I
it
hope
mean
it's
for
not one
us?
of those drunk tweets.
So hopefully not. So you tweeted one of these days that, and this was your exact tweet. Like, I recognize that mistake. I've worked on so many things, starting with DigiCash, where we thought we were so special that we couldn't lose at all. However, it's never enough. We can always lose. It's never enough. It's never enough, and we have to try harder. So, are you trying to send a message to the Bitcoin community? And if so, what is it?
Yeah, I really feel that. There's a thing that my community has made a mistake over and over that I've seen for 2 decades now, which is a feeling of, inevitable success based on some argument, like you have a special feature that nobody else has. And by you, I could mean either like a company that's making some product, like DigiCash was a product. It was a privacy preserving internet currency in the 90s. And the narrative at DigiCash was that people would eventually need to transact on this new internet thing that people were starting to use more and more, which at the time was pretty much a non-commercial world, and that they would never be able to use credit cards and bank accounts and things like that for that purpose, for various reasons, especially privacy, because no one would ever be willing to risk their credit card number by typing it in to a web browser. Therefore, DigiCash was the only game in town. And that turned out absolutely wrong in practice, right? And therefore, all of the science and product development and work that we did at DigiCash didn't reach people directly. It may have had indirect effects by other people learning from it and so forth. But that, as a product and as a company, was a failure. And I've seen the same kind of thinking over the years in many different fields of this sort of cypherpunk, privacy-preserving, individual empowering technology. And it's based on a good reason that that empowering individuals really is valuable and important. And there are often not very many competitors that are also trying to empower individuals, but it's not sufficient. That doesn't make you win, right? And I think at least whenever I wrote that tweet, I wasn't drunk, by the way, but whenever I wrote that tweet, I was perceiving the Bitcoin community, or some specific people, I suppose, I don't remember who, as having that same overconfidence that Bitcoin is so special and does something that nothing else does, and therefore we can like take our time to do it right, or whatever other. We don't have to worry too much about some aspects, and I think that's really wrong. What I meant by that we have to try harder is mostly that we have to connect to more and more users. and by connect, we have to give them whatever it is that they really want that they can't get from anywhere else.
I completely agree. And it's interesting, having gotten into Bitcoin in 2013, it's just sort of before it was all taking off. At that time, I made that same mistake in a way that, I would see that a lot of, the flaws of the existing system, and then you see this vision of a different world where everybody uses Bitcoin and everything works so much better in many ways, and it's really obvious to see that. But sort of like how you get there isn't obvious at all. But just somehow a lot of people, including myself at that time, make the assumption that because the end destination is a consistent vision that's compelling, therefore we must also get there and be on the way, which is completely wrong.
That's really well put. Yeah, it's such an inspiring vision, and it's good to have an inspiring vision, but it's not sufficient. We have to try hard to get there, and we might fail, but hopefully we won't.
Okay, so now let's dive into Zcash. First question is, why are you building Zcash, and who are you building it with?
Yeah, starting from, I was literally 19 years old, so more than half of my life ago, I discovered the science papers of David Chaum, the great cryptographer who's the father of most of the crypto ideas that protect privacy on the internet. And I just specifically his papers about privacy preserving money. And starting from then, my great inspiring vision that I thought was so wonderful was an entire world of humans that were freed to collaborate and cooperate with one another by an information system, namely the internet, and a money system that allowed them to find and organize with whoever wanted to work with them. I thought that was so important because I think almost everything that we all value in life, like having good relationships with our families and having education and peace and safety and the opportunity to learn and accomplish new things and grow as people, all of that depends on the economy, depends on having opportunities provided by collaborating with other humans productively. So starting way back then, I thought that was the best, most important thing I could imagine. And that thing is an open financial system with privacy and fungibility. And then, but it wasn't possible. It was a vision that there was no path to until Satoshi solved the open financial system part of it for the first time with Bitcoin. And then the scientists who came up with ZeroCoin and then Zerocash added in privacy and fungibility on top of an open financial system, which is easy to say in one sentence, an open financial system with privacy and fungibility, but it requires some real technological and cryptographic breakthroughs to actually make that real. So that's why I'm working on Zcash. Does that answer the question?
Yeah, it definitely does. I mean, like with Zcash, it's like we have an open financial system and we have privacy. It's like we have two things that seem contradictory in a way, like you need an open ledger so that we can validate it, but we also want privacy, and it seems like mutually contradictory, and it might have seemed so to Satoshi as well, whoever he or she may be. But it's like beautiful and interesting that this is actually possible and that we are going to build it as a community, and we're going to popularize these kinds of systems. That's an amazing thing. Now, though a second part to the question is like, who are you building this system with? What's the team?
Oh, well, it's not just me. The thing that I'm proudest of so far is in my my experience as being CEO is recruiting the best people and keeping them on my team. We have 5 engineers. You can go to our z.cash is our website. Z.cash is a pretty cool domain name. And the team page on there shows all of the people currently contributing. We have 5 engineers who are super great security hackers and crypto hackers. They're a really rare breed. And we have all those scientists who invented those protocols, including Ellie that you previously had on the program. I have to say that when we announced the existence of Zcash a little while back, my second favorite coverage of it in the press was the fact that it was in the print edition of Wired, because I started reading Wired when I was like 18 years old, you know, when the first edition of Wired came out, and I was able to go down to my local supermarket and take a photograph of the physical Dead Tree edition of Wired with Zcash in it on the shelves there. But my first favorite press coverage was a Bitcoin blogger who wrote a blog post saying there's this new announcement of this thing called Zcash, but there's something fishy about it. I think it might be a hoax announcement because the team is too good to be true. I love that. I feel the same way.
Yeah, that is amazing. So how do you explain Zcash?
The first simple explanation is to say, well, you know about Bitcoin, right? And the person you're explaining it to says, oh yeah, I know all about Bitcoin. It's an open ledger. And the simplest explanation of Zcash is to say it's an encrypted open ledger. So all of that data is there in a canonical, replicated, global ledger, but all of the data is encrypted and can only be viewed by the right people. That's the simple version.
And also, let's also have the complex version, because we did ZK snarks. So for our viewers that are viewing this episode first, you should maybe for this section you should go back and check out our episode with Eli Ben Sassoon, who is a professor at Technion, and he explains the fundamental primitive, the fundamental cryptographic primitive that Zcash uses, and that's called a ZK snark. It's something like in the 70s you had the invention of public cryptography. That didn't exist before that, right? And public cryptography created new kinds of systems that like pioneers in the 60s couldn't have imagined. And our the thing that is coming in our lives, which is like public crypto, is this thing called a ZK snark. So you should go back and see what it is, and it's needed for this podcast. But assuming that section is there and our viewers understand what ZK snarks are, like describe how the ledger works using that terminology one layer deep.
Okay, yeah. So for the purpose of this discussion, snarks are also known as zero knowledge proofs, are a way to prove some sort of computational fact about some data without revealing the data. And so the way we're going to use it is that there's a fundamental, like you said earlier, sort of fundamental contradiction between an open system and a privacy and fungibility preserving system. And the simplistic description of Zcash as an encrypted open ledger, if you're familiar with Bitcoin and cryptography, your eyes start narrowing and you say, wait a second, you can't have an encrypted open ledger because the miners and full nodes won't have any way to validate transactions. So they won't be able to reject invalid transactions from the ledger. So that's the fundamental problem that snarks are a solution to. So a snark, since it can prove some facts about some encrypted data without revealing the encrypted data, we can use it. So the simple model that I use when talking to people is that Bitcoin is a open ledger of sender address, recipient address, and amount transferred. So it's like a database with 3 columns, spreadsheet with 3 columns. And Zcash is the same, except all 3 of those columns are encrypted. And then it has a 4th column, which is the proof, or the snark. The proof is a proof that the data inside the encryption in this row correctly satisfies some validity constraints. And the constraints are the obvious thing that the sender did have that money and hasn't double spent it to someone else already. So that's one layer deeper. And it gets a lot more complicated the closer you go into the protocol. But that explains, that's like accurate enough description of the Zcash protocol, and it explains why snarks are a necessary component of it.
Let's take a short break to talk about the GTech blockchain contest. GTech, the German Tech Entrepreneurship Center, is a new center in Berlin for entrepreneurship, and they want to support exciting projects happening in this space. So that's why they're running a blockchain contest together with RWE, which is one of the largest energy companies in Europe, and Globumbus, a foundation supporting entrepreneurship.
You can participate by submitting your idea for your project and win up to $50,000 in free grant money. That's equity free. You just take the money and do what you want with it. Anybody can apply, whether you're an early stage startup and perhaps you just have an idea, a blossoming idea, and or you can apply if you've already raised funding and are well on your way to becoming the next multi-billion-dollar company. And anybody can apply, whether you're in Berlin, in Siberia, in Shanghai, or in San Francisco. There's no geographical restrictions, and anybody who applies can win up to 12 months of free office space in Berlin, free mentoring, legal support, etc. Of course, that's totally optional. If you want to stay in Siberia and work on your blockchain startup, you can also do that.
The application deadline is March 31st, so make sure you submit your idea as soon as possible. You can learn more about the contest and apply by going to epicenterbitcoin.com/GTech, that's GTEC. And we hope you'll win, we hope you'll make it to Berlin to collect your money and that we'll get to hang out in person. Now we would like to thank GTech, RWE and Globumbus for their support of Epicenter Bitcoin.
So perhaps we could walk through different perspectives, right? Like in Bitcoin, we have in order to describe Bitcoin, what the way I would do it is I would put the person I'm trying to explain it to in the shoes of a user, the shoes of a recipient, then the shoes of a miner, and then the shoes of a full node owner. And then once he understands all the four perspectives, it's like, okay, this is how the whole system connects, right? So perhaps you could do the same for Zerocash, right? So
well, it's mostly the same as Bitcoin, right? The miners and full nodes in Zcash are ideally they're validating all the transactions. The miners are also adding proof of work on top of the transactions and getting a reward from the monetary-based distribution schedule. This is all the same in Bitcoin and in Zcash. So the difference from the point of view of a miner, well, for one thing, we're going to change the proof of work. We can get to that later if you want. But the other thing is, the main thing is that the miners are also, as part of the validity checks, are checking the zero-knowledge proofs that are attached to each private transaction. So that's the only difference from the point of view of a miner. Does that make sense?
Yeah, and so what about a full node?
It's the same, except if you have the private keys that give you access to transactions, then you can detect that some of these encrypted transactions are money for you.
So that means you have to check every single transaction, right? If there's some money in there for you. And also, for example, if you have a, it's easy for, you have, let's say you have some web wallet, and the web wallet, of course, knows, what are the private keys, what are the addresses that you own, and, you can.
Just let me interrupt. Does a web wallet mean you're a dumb web browser and you're relying on some third-party service to hold your private keys?
It could be either, I guess. So it could be something like, blockchain or info, where it's like private keys are in your browser encrypted, right? But it knows what public keys you have. It can ping an API and know, okay, here's the balance. So this isn't possible, right?
So this is what they call a light client.
Right, yeah.
Yeah, or an SPV client, they might call it.
Or it can even be if you're blockchain or info, it's not even a light client, right? It's just because it doesn't do SPV proofs. So it even you can just ask an API.
Yeah, there are different sort of levels of delegation of vulnerability to a third party. The different kind of more or less light clients could use. I don't know for sure all of the consequences of Zcash's privacy for light clients. Maybe some of the other members of my team have, I know some of the other members of my team have thought more carefully about light clients than I have at this point.
So, for example, let's say, so for convenience, let's like imagine, like you said, a spreadsheet, right? So a spreadsheet has 3 rows. The first row is the public key or address. So it would be like Zuko's address, Brian's address, Meher's address, and so on. The second row has the value. Generally, in Bitcoin, you would imagine it as having value, right?
You mean column, right?
Yeah, see,
If it's a spreadsheet in that
Yeah,
layout,
yeah.
okay, fine.
So column. So the second column has value. And with Bitcoin, the way, so if I want to send money to Brian, what needs to happen is in this spreadsheet, let's say I'm sending 5 Bitcoins to Brian, then from the row corresponding to my address, 5 should be subtracted, and then it needs to be added like +5 to the row in which which corresponds to Brian's address, right? And so to do this, I create a transaction, which is essentially a way of me saying to the Bitcoin network, hey, subtract 5 from mine and add 5 to Brian's row. And then I sign it with my private key. Now when I do this signature, some node can actually check my signature. And because it has this spreadsheet, open spreadsheet, it can go and say, okay, Meher has enough balance, like enough money to make this transaction. So let's subtract from him and add from Brian, right? Now in Zerocash, what you're saying is this spreadsheet looks a bit different. So there is the account number and there's the amount, but it's encrypted. So like there's one row corresponding to Meher's account and amount, but that's encrypted. So the node or the miner doesn't know how much is the actual value.
Correct.
And similarly, the one for the row for Brian is like that. So I need to create a transaction, and the miner needs a way of knowing that I have enough money. And is this the part that ZK snarks are solving?
Yes, that's what the snarks are for, is to make it so the miner can reject a transaction from someone if that person if their private key doesn't actually control enough money to make this transaction. So it would be, I think it would be too much detail to go down another level of detail and talk about the actual like layout of the values in the crypto protocol. But the effect of it is the fourth column in that ledger is a proof which, because of the amazing properties of zero-knowledge proofs, we know that, so we don't know the sender address, the recipient address, or the value transferred, but we do know that nobody could have created this here proof in the fourth column. I'm holding my hand out over here. Nobody could have created the proof that comes with the other encrypted values unless they have a secret key which controls sufficient value to cover the amount that's getting decremented.
Mm-hmm. So basically, like a Zerocash transaction, like if I look at a Zerocash transaction, this could be anybody in the world sending money to anyone else in the world, and it could be $1 billion or a 50 cents, and it all looks the same to me, or it looks similar to me. It looks garbled.
Right, and that's a good example of the difference between Zcash and the other privacy technologies that are for adding privacy to open ledgers. There's a lot of them with different kind of trade-offs, but Zcash is the only one that is sort of universal. Like all of the information has been hidden through encryption. Well, almost all. Like as much as much as you could do with cryptography is done by this in terms of omitting information from leaking into the public blockchain. And just as you say, that means that the sort of bundle of transactions or key holders that your actions are mixed in the crowd with is everyone. It's like the biggest possible crowd. It's all users of the system. Now, there is still some information that can leak in terms of timing and in terms of blockchain, like how up to date you are on the blockchain. Okay, but that's sort of inevitable because of the fact that time passes and blockchain synchronization takes time. By which I mean to say, if you make a transaction and then someone else joins the network later and buys some Zcash and then they make a transaction, someone can tell the difference between those because they happened at different times, right? So there is information that just about the times that transactions happen. So if you're like Chainalysis and you're looking at the Zcash blockchain, I don't think it's a very interesting visualization. It's just a sequence of timestamps of when a transaction occurred.
So just briefly, so with blockchains and with Bitcoin, there's a whole range of things that people are excited about it, but one of them has also been actually the aspect of transparency. So many people have been excited about, for example, the idea of, let's say, a nonprofit that is purely Bitcoin can run their accounting fully public. Everybody can inspect it, or one can also imagine a lot of other scenarios where I make a payment and I want to prove to some other party that I made that payment. Does Zcash remove all of these possibilities, or can I selectively prove to other parties certain things about transactions I've sent or received?
Yeah, absolutely. It wouldn't even be possible really with cryptography I don't think it would be possible to make a system where you couldn't prove things to other parties because you have secrets controlled by your client software. And if you reveal those secrets or some cryptographic derivative of those secrets to another party, that can serve as a proof to the other party. So this is a part of the Zcash design which is not finished, at least not as well sketched out as I would like it to be. There are different levels or kinds of being able to selectively reveal information to other people. In the current Zcash design as it's currently running on our alpha testnet, you can reveal specific transactions, and anybody that you reveal them to is able to look at them in the blockchain and verify the clear text contents, right? Because every row in this encrypted ledger is encrypted with a separate encryption key, right? And so if you reveal the decryption key to one of those rows to someone else, that allows them to see that transaction in the ledger. Make sense? So that's sufficient, I think, for like the proof of payment use case, and maybe a lot of use cases. The whole overall term for this kind of thing that we use is selective transparency. Like Bitcoin is mandatory transparency all the time. And if you want to get privacy, you can try to kind of claw some back with various techniques, but you're starting with everything being transparent all the time. And it's a common misunderstanding for people to think that Zcash is the opposite and it's everything confidential all the time. Instead, Zcash is selective transparency, where you can reveal the specific things to specific people.
And revealing those things, of course, doesn't create any vulnerabilities that, I can prove I got this money, but then also it means that the other person can steal my money, or there's nothing like that.
Right. So in the current version of Zcash, you can reveal specific transaction, the history, the past, the current existence of a specific transaction in the blockchain without giving away any other of your authority to control your own money or other information of your history. I'd be interested in people's feedback about a possible future extension to Zcash that we've sketched out a lot of the cryptography of it, but we're probably not going to put it into Zcash 1.0 mostly for engineering timeline reasons. And that would be what we call a view key, which is a thing you can give to someone to reveal all of the transactions associated with a specific payment address. And the thing that I'm wondering about is, are there use cases that are important? Like I imagine you said the nonprofit example earlier, where you want to prove to the world that, like, you want to show the world an accounting of all of the donations you've received, or you might want to show the world an accounting of what you're spending it on, or maybe only one of those two. And similarly, like a company or a business partnership or a nonprofit organization has a treasurer, and that's the only person who's authorized to spend the club's money, right? But all of the members of like the board of directors or whatever of that club are authorized to view whatever the treasurer does do with the money, right? So that would be a use case for what I call a view key, which is where the treasurer would have the spending key and would give to all of the members of the board of directors a copy of the view key. And with the view key, they could tell all of the transactions that spending key has done. But that's not currently in the current protocol for Zcash. But I can't tell if the thing that is current, the kind of selective transparency that is currently in the Zcash protocol is good enough for the use cases. That's the kind where you can selectively reveal specific transactions. See the difference?
Yeah, I can see the difference. I mean, this is something we've wanted to circle back to briefly later. It's a sort of application of Zcash in other areas, but or technologies like that. But I can especially see when you start getting into like more complex smart contract type things that the selective revealing of information is going to be really critical. So having a lot of capabilities there will probably be extremely valuable.
Yeah, that's what it feels like to me too. It kind of feels like to me that with the right selective transparency functionality, that Zcash is a superset of Bitcoin's functionality, because the canonical shared source of truth property in Bitcoin, I mean, it's also in Ethereum, but Bitcoin is the pioneer of it. Having a shared source of truth is a novel and potentially really valuable, powerful tool. And it feels like to me there's an even more general purpose and more powerful tool that could exist, which is the shared source of truth blockchain, but you can only see the subset of it that you're allowed to see given the view keys that you can peer through to look at the blockchain. So I'm very interested in that use case, and that's probably, like, we're going to ship Zcash 1.0 very soon, and it's going to have the aforementioned limited form of selective transparency. I didn't want to get into too much detail, but there's also a possibility in Zcash 1.0 to share a key that I think, I could be wrong, but I'm like 95% sure at this point that there's a way to share a view key, a kind of view key that reveals all of your incoming transactions, but not your outgoing ones. And also only the ones that, yeah, that's basically the fact. So I think I'd be interested in your and other people's feedback on this. I think the notion of a shared canonical global source of truth with overlapping controls over who can see which subsets of the truth is potentially really important. And what we're about to ship in Zcash 1.0 is sort of the first step, which it solves at least part of that. But I'd be really interested in whether that's good enough for specific use cases.
Yeah, I mean, sort of if you look at the smart contract, so I work for Eris, so there's a lot of thinking of smart contracts and how one can implement complex processes there, and that's I think really critical, because the privacy selective revealing thing is really complex, and it's going to be really important. So yeah, I think this is
because when you add smart contracts, it's really important, because then you need to delegate to. It seems like to me that if you're using smart contracts, then you need to give computer programs the ability to view certain subsets of the blockchain's source of truth, right? And I think it's really important when designing such systems that you're able to give computer programs the ability to view what they need to view without thereby giving them the ability to view other stuff. Because if they get unnecessary excess authority to penetrate confidentiality, then that can be exploited. Does that make sense?
Yeah, that definitely makes sense. I mean, yeah, it looks like it does look like a superset of Bitcoin.
Today's magic word is privacy. That's PRIVACY. Head over to letstalkbitcoin.com to sign in, enter the magic word, and claim your part of the listener reward.
What are kind of the performance characteristics of this system? So let's say I want to spend some Zcash, right? And I want to send you some Zcash. How much time does it take for me to create a transaction, and how much time does it take for the miner to verify that my transaction is correct?
The current alpha code that we have running on a testnet, it takes like about a minute or two of CPU time to generate a new privacy preserving spend, and only like a few milliseconds, I think, to verify. The latter part is really good performance, and that's really important because all the full nodes and miners have to be doing all those verifications all the time. The former part is pretty bad, because it takes a whole minute or two on like a laptop 64-bit high-powered supercomputer CPU. It also takes a ton of RAM, like probably more than 4 gigabytes of RAM, I think. We haven't measured it yet precisely, to generate a new spend. So that is totally prohibitive for certain use cases, like generating a new spend on your smartphone, for starters. And anything that's got a real low latency requirement where you get incoming money that you receive, and then like a millisecond later, you need to spend that money to someone else right away. So that's totally impossible with the current protocol. But there might be ways around it, because if you can receive, if you have a buffer of money, you can spend it using a privacy preserving payment, so that so there's no linkage between where it came to you. Then you can privately spend it to like a new address, right? So there's no linkage in the blockchain between where you got it and that new address that currently controls it. And then you could do a non-private spend of it directly from that address. This is a thing that we haven't talked about in this podcast, but Zcash contains all of the Bitcoin protocol. It's a clone of the Bitcoin code base, and it's a superset of the Bitcoin protocol. It's the Bitcoin protocol plus the privacy preserving spend. So that's the only one. The new transaction is the only one that has better privacy properties. Everything we talked about the encrypted ledger is only when we're talking about the privacy preserving spend transactions. Make sense?
So you have the option of doing a privacy preserving transaction, but you also have the option of not doing one.
Right.
And just doing a regular transaction that would be as fast and as easy to generate as a Bitcoin transaction.
Exactly. And you get exactly the same privacy properties as you got from Bitcoin with those kind, but potentially better, because the existence of the privacy preserving transactions means that they break the links of the chain of transaction history. Makes sense? So if you're looking at like one of those Chainalysis views, if there's a series of globally transparent transactions that don't use the privacy feature, you can see them. So if you're looking at, if you had some kind of visualizer like Chainalysis and you pointed at the Zcash blockchain, you would be able to see chains of transactions of anybody who, of any series of transactions that use the globally transparent protocol. But whenever that transaction that chain terminates in a privacy preserving protocol, one of the Zcash spends, then you don't know like where else in the whole blockchain it went, right? So that it really, except modulo those timing issues I brought up earlier, it really protects the privacy of the whole and the fungibility of the whole system, even though there are short chains of globally visible transactions. So the main reason, there's several really good reasons why we're keeping the globally transparent protocol in there. One is backward compatibility. If you are running a product or service or hacking something on top of Bitcoin right now, you can switch or add Zcash as a backend, and it's all the same. Everything continues to work the same as it did before. And the other is that there's a bunch of functionality in the Bitcoin or the globally transparent protocol that we can't do with the privacy preserving spins, like multi-signature transactions, right? Those are really, really important in Bitcoin. There's a lot of really cool things being built with multi-signature transactions. And so Zcash can do multi-signature transactions using the globally transparent subset of the protocol. But when you want to do a privacy preserving spend, you can't do multi-signature. You can just do a direct payment.
So okay, that seems like a very very interesting point. So before we go on, just translating what you said right now in another language, it's like if I suppose, let's say I own 100 Bitcoin, and every month I realistically spend 2 or 3. Most of the money I don't spend. So what I could do is keep most of my 100 Bitcoin in the privacy part of the ledger, and at the beginning of the month bring out, say, the 3 I want to spend in the public part, and I can spend these 3 like normal Bitcoin, very fast transactions, etc. And if there's some balance left over in after the month, like let's say there's that's 0.2 Bitcoin left over, I could then put it back into the private section of the ledger as well. So somebody can't figure out that I actually own 100 Bitcoin.
Well, that's correct. That's what I said. I do want to emphasize that we don't know for sure. That kind of puts, when you use Zcash like that, it kind of moves you a little closer to those lesser privacy solutions out there where it seems like it should be pretty safe, but exactly how safe it would be would depend on how smart your attacker was and how much they knew about you, right? Because if there's somebody who's like targeting you, like there's a criminal that's planning to extort you or rob you or something, if they know stuff about you, like if they can tell what times of day you connect to the internet or what kinds of things you like to buy with your money or other information, they might be able to correlate that with the transaction information that's revealed by the hybrid usage that you just described, okay? So it's not, earlier I said that Zcash offers sort of the maximal possible privacy that cryptography can provide, and that is true if the only thing you ever do with it is the privacy protecting spends, right? Then you're putting as little information as possible about your behavior into the blockchain. But because, like you said, like you asked about the performance, the current implementation and the protocol itself has these performance consequences which may preclude using privacy protective spins on like all devices or in all use cases, plus which everybody might need multi-signature transactions sometimes, and so we can't do those with privacy protecting spins right now. So it gets more complicated in terms of the safety analysis.
Let's take a short break so we can go to Paris. I stopped into La Maison du Bitcoin, situated in the heart of Paris' startup scene, and I met with Eric Larchevêque, Ledger CEO, to talk about the Ledger Nano.
The Ledger Nano is a Bitcoin hardware wallet based on a secure element. It is on a USB form factor that you plug directly inside your computer, and it will manage all your private keys. The signature of transactions will be done inside the secure element, thus never revealing the private keys to the host computer. It is compatible with our own Ledger Wallet Chrome app, which you can also use for multi-signature with Copay or CoinKite, and a large range of third-party applications such as Mycelium, Electrum, Greenbits, Green Address, and so on. The Nano also exists as a cool bracelet wearable, so you can always wear proudly your Bitcoins on your wrist.
The Ledger Nano is an easy-to-use hardware storage option which doesn't compromise on security. If you want to get a secure setup for storing your Bitcoins, go to ledgerwallet.com and use the offer code EPICENTER to get 10% off your order. We'd like to thank Ledger for their support of Epicenter Bitcoin.
So let's move on to a couple of common kind of questions, like questions people have about zero cash. These are like kind of challenges to the system. So one of the questions is that like for viewers, like for people who have been in the Bitcoin space for a long time, they might remember that in 2010, very early days of Bitcoin, there was an event where a guy figured out how he could create billions of new Bitcoin. Like he could easily cross the 21 million limit. This was because he could create transactions that the miner would accept as valid, and that transactions would end up creating new Bitcoins. And then Satoshi at that time and Gavin figured out that such a thing could exist. Like this person told them so, and they changed the protocol to not allow that kind of transaction to go through. So this wasn't the case of an implementation bug where somebody could create Bitcoins because the rules of the system were not, let's say, as proper as they should be.
Mm-hmm.
Now, in something like zero cash, if there's an implementation bug like that, then the attacker could create coins, and those coins would be completely private. So nobody would be able to even know that new coins were created. Like if I were to like say Zcash was released and I figured out an implementation bug like that, and I created new coins, and I could basically keep on creating them all my life and live a good life just on that. But the other people suffer inflation. So this kind of seems to lead to the expectation that like zero cash has to be very, very well engineered and almost be like bulletproof against these kinds of things. Do you think there's some other way by which you could address this doubt?
That's a really, really good question. That's one of the things that I'm most concerned about. Now, for starters, Zcash is really, really well engineered. We started with by cloning the most recent or a recent version of Bitcoin Core. And the reason we did that is because Bitcoin Core has been running in production for so many years, right? And bugs like that, of which there have been more than one, security flaws of various kinds have been found and fixed, and a lot of people have studied it and audited it, and we have higher confidence that there aren't a lot more such flaws in Bitcoin's code base. Likewise, with the code that we're adding to do the privacy-preserving transactions, we're being extremely careful. Like I said at the beginning, my team is absolutely world-class experts at this kind of work, and that doesn't mean that we don't make mistakes. But we're doing a really, really good job of being careful about things that risk inserting bugs like that. But that's not really very satisfying to me. I don't like having sort of all of our eggs in the prevention basket and none in the detection and like correction side. But doing it like that, having no good detection of that kind of bug it seems like kind of sort of an inevitable consequence of the strong privacy properties. Anything that had such good privacy might also have such problems with public validation of the correctness. That said, we have some ideas. Actually, I recently blogged about some of these ideas. We have some ideas of how we could extend Zcash in the future, possibly. It might not work out. It's one of those forefronts of science that you can't know in advance what is going to turn out to be possible. But it might be possible to do some kind of privacy-preserving auditing of the size of the monetary base. That would probably reduce the privacy of, well, probably not the fungibility. It would probably reduce the privacy of the currency a little tiny bit, but very little. And in return, we might be able to get better assurance that there hasn't been that kind of counterfeiting of currency. It's definitely not planned for Zcash 1.0, right? Our plan for Zcash 1.0 is just the simplest thing that could get privacy-preserving payments into the world in a real live blockchain as soon as possible. But I'm definitely concerned about that topic, and so I might prioritize it. If Zcash 1.0 is successful enough that people want to use it and that it's valuable, then I might prioritize trying to further strengthen it and add that kind of sort of belt and suspenders extra defenses.
Well, Zuko, just before we started the episode, you talked a little bit about the sort of culture and the need to be open for change. Can you share a little bit about how you and Zcash looks at that?
Now, I'm not slagging the Bitcoin people. I want to emphasize, as I've made clear all along, Bitcoin is wonderful both as a technology and as a community. And the Bitcoin devs and Bitcoin companies are my close collaborators and cypherpunk fellow travelers all along. But there's a way in which the Ethereum culture has differed from the Bitcoin culture, and I really like the way Ethereum's doing it, and I want to emulate that, which is that the Bitcoin sort of ideal has sort of centered around getting everything right the first time and then never changing the rules again. And there's a lot of good reason for that, because changing the rules introduces uncertainty, which can distort people's economic decision making. And if the rules are mutable, then there can be harmful politics in which people try to change the rules for bad reasons, for their own good, selfish interest or whatever. But Ethereum has adopted a different culture, which I totally approve of, which is that these are early days and none of us know what we're doing. The science is in its infancy, and in 5 years, we're going to know so much more about what's possible and what's impossible scientifically. We're going to know so much more about what people value, how people use these things, whether people use these things. And so the Ethereum culture, from my perspective, and I'm no expert, I could be totally wrong, but it seems to me that the Ethereum people are have sort of a informal social contract that we're going to be upgrading this year after year, and the new thing could turn out to be radically different from the old thing. And culturally, we all accept that within Ethereum. Now, the risks of damaging economic consequences or political exploitation are those risks can be, I think those risks can be controlled because there's no coercion in the system. You can't force anyone else to adopt your new thing. And so so the only way you can get an economically meaningful new thing deployed is to get a mass. It doesn't have to be everyone, but it has to be a lot of people for it to be economically valuable to anyone. And you have to get all those people on board. They have to voluntarily, consensually opt in to using your new thing. And so to me, that's the most important defense against a upgrading, evolving system being exploited for someone's illicit gain. So in Zcash, what we're intending to do is communicate to our users that we're the evolving kind of project. And if you're the get it right and never change it kind of people, that's okay too. You can just pick one of ours and keep it, and you don't have to upgrade to the next one. But I'm hoping to get a large mass of people who want to continually upgrade their economic system with better and better features, because there's a lot out there in the future that we want to add and improve.
Yeah, I mean, it's strange that I myself kind of had the feeling that the whole crypto space, kind of Bitcoin, cryptocurrency people, they're divided into like kind of like two camps of people that want like contradictory things, and the problem is that both of them till today are focused completely on Bitcoin. There's the one camp that just wants, something like digital gold, like something that exists and doesn't change, and that's it. And then there's people I identify with, and I'm part of that camp, which is like this technology is going to need 20 years to come into society, and there's going to be like loads of iterations on the way, and maybe just the thing that comes into society will be built by somebody who hasn't even been born yet. So yeah, so the idea that we should fear hard forks is, to me, it's a strange idea. I mean, like, we are all pioneers. Like us not hard forking, and like not hard forking because people like me who are running nodes won't do an sudo apt get upgrade. It seems a bit strange to me, but like the community is part of, like, there are these two pieces to it, and I think Ethereum really does it really well, and I'm really happy to hear that even Zcash would want to be in that direction.
Let me interrupt. I mentioned early on that I think there's so much to learn from the experience of the empirical observations of real life deployment, and that's why Zcash is almost identical to Bitcoin. There are 100 beautiful ideas, some of which some of us are the authors of, for experimental new cryptocurrency concepts. And we, with great reluctance, decided we're not going to do any of those in Zcash. We're just going to do Bitcoin plus privacy, because nothing else has the empirical evidence of having worked in the wild under attack for years and years. But there's some new empirical evidence coming along, which is that Ethereum is working, right? And so that's really, really valuable to me to be able to learn from two projects which do various things differently from one another, and they're both working to varying degrees. So that's what that encourages me to follow some of the Ethereum development model and governance model.
Well, Zuko, so we're at the end of our episode.
I want to keep going.
I know, us too. So we have like a whole lot of other topics that we wanted to talk about, but fortunately we'll have Zuko back on when, hopefully not too far future, when Zcash launches. With that is one question we do have to ask before we wrap up. What is the timeline here? When do you expect Zcash 1.0 to launch?
Okay, I'm going to swallow and take a deep breath.
July. Okay, excellent. So we'll have you on at latest by July, perhaps a little bit before that, so we can talk about a whole lot of economic aspects around the currency, some of the governance stuff you've talked about, maybe how you can actually make sure that Zcash keeps evolving, how that's exactly going to work, also proof of work, how you're approaching that. There's a lot of topics we want to talk about, and perhaps there'll be also some new things on the technology level that we can dive into. So this was a fantastic episode, and I really look forward to coming back and going even deeper into the topic. I think this is
so much.
Yeah, I think this is a really exciting project, and hopefully it's going to be one that we can keep coming back to.
Great, thank you very much. I look forward to the next edition.
Okay, perfect. Well, so thanks so much for listening. So we put out these episodes every Monday. If you want to listen to them, you can get them in any podcast app you use, or you can watch videos on YouTube at youtube.com/epicenterbitcoin. And we're also part of the Let's Talk Bitcoin network, so check out some of their other shows at letstalkbitcoin.com. And if you want to, you can leave us a review on iTunes or somewhere else, and just email us at show@epicenterbitcoin.com, and we'll send you one of those t-shirts, plus stickers. I think we have some stickers now, so that as well. So thanks so much, and we look forward to being back next week.